All right, thanks for the likes. I'm going to set up my background to show my YouTube link so that I don't have to keep telling people that you're more than welcome to go to YouTube and you can see the full screen. Let me change my TikTok background. And if you're on YouTube, thanks for watching. This will be boring for a second. If you're on Twitch, this is going to be boring for a second. If I were more competent, I would have done this before I hit the start button. But you know, c'est la vie. Green screen. This one. Boop. La 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 la. Finding the picture. Finding the picture. Okay, I think that's it. Full screen at youtube.com/c/John Vandeveer. Sign up now. All right, cool. So with that, let's dive in. We got 2 Leetcode hards, and we got about an hour 15 to do them. Yeah, and you'll get to see my Leetcode approach. Like, I do not care. I'm down to look at the solution. I tried to take, for these, I'm trying to take a kata approach where I just drill them. So the point, like, I've already gone through these problems and understood them at some point in time. If I'm forgetting them now, I don't feel bad about looking at the solution because the point is to drill them so that I can memorize them. If I'm failing to remember the solution already, that's already a sign that the drill isn't working. So the point here is not to understand like algorithmic procedures. I already know the algorithmic procedures for these problems. The point is I need to be able to snap them out quickly. Like if you can do 2 hards in an hour, I feel like you're good. So yeah, this is an array of k-linked lists, and we're just going to merge them. Each linked list is sorted in ascending order. That's our cue that we can use a binary approach. Not binary search, but like it's going to be a reverse binary search, basically. It's going to be, we're going to pair the lists off 2 at a time and merge them 2 at a time. So it's like an inverse binary merge, which sounds really fancy, but like all these algorithms sound so fancy, but once you do them, it's really not. It's just like, I don't know, the words we picked to do it for some reason. So here we go. First, I'm going to do them 1 at a time. It's going to be like a linear merge. That's going to be inefficient, and then we're going to tune it to use a binary approach. So yeah, I've got some pseudocode right here. Start by merging lists together 1 at a time. If we have time, implement binary search. We will want to make sure lists themselves are sorted starting by index, then use merge sort. Repeat until a single list is left. Can use BFS over DFS for no chance. That should say no change. For no change in time complexity, but reduce mem complexity. So if you do depth first on this problem, I think it's O and K. Look, I'm going to jump right to the solution. Like, I do not care. I want to remember the time complexity. I think in the worst case, it's O and K. Shit, no, I think it's ON. So this will be solution 4, 1 by 1. Dang. Merge list 1 by 1. There's no code there, huh? Okay. So, yeah, maybe I should remove that comment, right? Because it looks like it doesn't matter in this problem. I think I was thinking of a different problem. So it's constant space. This should be constant space solution. All right. This is bullshit. All right, cool. Target space complexity should be constant. Should be constant. All right, so let's dive into the code. We are going to want a helper function. The helper function is The helper function is what actually does the merge sort. So this will be merge sort to lists. And then in the naive case, we apply that to the first two, and then we grab the second one, merge it in, third one, merge it in. In the more efficient case, we're pairing them off and doing two at a time, then rinse and repeat. Which apparently adds. You see how it's levels? Like you have to pair them off, and then there's a new level, and then you pair them off, and there's a new level. So I was thinking those levels would impact memory, but apparently no. We're just going to use the given lists and point at them, which, yeah, is way more efficient, right? L1, L2. Oh, geez, I can't remember how to do a merge sort. Do you always start with commenting before you code? Absolutely yes. Absolutely yes. Okay, so lists, I'll say while lists.length is greater than 1. Then we're just going to keep merging them, and then eventually we will return what happens if there are no lists. Yeah, so you can see here in examples 2 and 3. Example 2 gives us no lists. We just return an empty array. Example 3 gives us a single list with no nodes. We also return an empty array. So, I could just return the lists here, but in this case, I need to return, like I need to take care of that nesting. That's a little edge that I need to consider. Wi-Fi is this programming language. So this is, I'm just using JavaScript. Oh, and let me open up my chat in case y'all are trying to chat at me from YouTube or Twitch. Cool, got the YouTube and Twitch chat open. I can see a couple people over there, but I don't see any comments. It might be the case that now that I opened the chat tool, like previous chat messages aren't coming through. I'm not sure. So if you did ask a question on YouTube or Twitch, feel free to just ask it again. All right. So while the list length is greater than 1, do merge. And then return, we can't just do this. We can't just do that. Because of the case of example 2 where lists is, well, no, it would be lists length 0. Yeah, so we can do a little check like this. List.length is 0. If it is, then we return this. Otherwise, we return. I think that works. So if the input lists is just a singular empty list, where I'm expecting a list of lists in the normal path of the happy path, but it could be an empty list, then I'm going to return an empty list. That's just a special case handling. Cool. So the do merge, we will say there's like cur list and next list, and then we merge them. That's it. So we'll say lists 0 equals merge sort to lists of lists 0 and lists 1. And then we want to basically delete lists 1. So how can we delete it, and in place we can splice it? Yep. And I might want to splice it beforehand. Yeah, so instead of list1, we'll do the splice. So this will be lists.splice. Difference between splice and slice is that splice is destructive. Slice is non-destructive. Slice like copies. Splice removes. It pops out from a location within. So we want to splice at the 1 index. And we want to splice 1 element. I think this is correct. Let's double check. Console.log. And you see, I'm already taking too long. Like, I'm already taking too long because I should just have this memorized in the kata approach. Return L1. For now, that'll be fine. So let's run that. Okay, yeah, sorry, got that syntax wrong. I need to arrow like so. I'm really just wanting to see 2 merge. 2 merge is 1, 3, 4, right? So I spliced out correctly. And the other thing I want to confirm is that lists was partially destroyed as expected. Yep, and list was partially destroyed as expected. So we confirmed that our splice works correctly. Is there a difference between an empty array and list 0? I'm new at JavaScript, sorry. Yeah, hey, no problem. No need to apologize, friend. So this is an empty array. There's nothing in it. And lists 0 is the first element within lists. So what this expression says is if lists has a length of 0, then it has no elements in it. So let's just return an empty array. But if it does have any elements in it, return the first element. Cool. Oh, thanks for the follow. And 300 likes and cooking. All right. Okay, so we spliced properly. So we need to do the merge sort. And honestly, I can't remember merge sort. So let's just look it up. Again, this is like a unique approach. This is a kata approach. So if you're trying to do like deep learning and understand the algorithms, you probably don't want to do this. But my thing is like, I already know what merge sort does. I just forgot how to write it quickly and efficiently. So here is basically the merge sort. And this is using a list node. Yeah, this is weird, right? Because we were given array of arrays. We were not given nodes. Is list node a Python built-in? So it's just a, it's not a built-in. Okay, it's not a built-in. It looks like in the Python implementation, they give you list node. Let's try out, I'm gonna switch languages over to Python real quick. Definition for singly linked list, class list node. Okay, so they give you that. They basically give you that. And they didn't do that in JavaScript. Oh, okay, they kind of did. They just commented it out. Yeah. So should I just uncomment this, or can I just use it? Let's try to use it. Okay, so I can just use this on any number, like 1, 2, 3, 4, 5. It just works on a number. So I'm going to try to say temp is list node of 5, and just log that and see what I get. Okay, I think I just broke a thing. I shouldn't have that while loop. Sorry. So temp is undefined. So there is no list node. Let's even just console.log list node itself. Oh, it is there. Is it because I forgot the new keyword? Yeah, okay. So Leetcode like injected this list node entity into my code. I wish that was more obvious that they did that. Okay, so this is how I can easily make it into a linked list. All right, great. Yeah, so it's a list of list nodes, which is not, it's okay, the quality is much better here. Yeah. How do you say your name, by the way? Jorde? It's so nice that you explain every step. Thank you very much. So as one user or one viewer can attest, the quality on YouTube is much better. Ooh, I got a medicine ball from Starbucks. Love that stuff. What the hell is up with this problem? It's not a list of linked lists. They did not give me a list of lists. They gave me a list of a list of list nodes. And okay, so I will create the linked list. But I disagree with the prompt. You're given an array of linked lists. No, I wasn't. I was given a list of list nodes, but they're not actually linked lists. Okay. So we are going to sort list 1 and list 2. We did splice it correctly. So we remove list 1 and then we merge them into list 0. And we repeat until the length is only 1. And we can do the list node like this. So I normally code with PHP, but as I told you, I'm still new. No worries. I started in WordPress, so JavaScript and PHP were my first languages as well. So what I would like to do is let L1 or like I'm going to have result. I'm going to have result. So how do I stitch these two together? I stitch them together. I'm just eventually going to return L1, actually. That's correct. Yeah. So I need to merge the nodes from L2 into L1 at the appropriate time. No, I'm going to do a new one. I'm going to do a new one. I'm going to do a new one, which is like result. And I guess I'll be using an array. This is not really a linked list. I'm looking at the Python solution here. Let's see. See, the Python solution is actually using a linked list. All right, let's just write it as written in Python. I'm not sure it's going to actually work for us. So they eventually return head.next. So they always start the head at 0. Is it because the values are guaranteed to be positive? You could use negative infinity. So they have head and point. Yeah, so this head is like creating the new list, and then point is like where you're pointing at on the list. And then we'll eventually return head.next. So I'll do this. Head is a list node at negative infinity. Let pointer, so pointer is going to be reassigned. So let pointer equal head at the beginning, but we're going to be reassigning pointer and will not reassign head. And This is how we're going to stitch the nodes onto a new linked list. While L1 and L2. Yeah, every step of this seems strange to me at this point. 1, 2, 3, 4. But the point of it is, the point of the kata approach is that we don't get stuck down in this minutia. We are just memorizing the minutia. We understand merge sort at a high level. The implementation is something to be memorized, not something to really dwell on. So if L1.val, well, L1 is not a list node. Oh, you know what? Maybe they are, you know what? Yeah, I think this is why it didn't make sense to me. I'm going to comment out this method, and I'm going to console.log the first element, and I bet it is a list node. It says undefined. Lists 0. Yeah, so when I log it, it appears to be an array, but it's actually not an array. See, if I try, so it says type 145. That would be the first list. So it looks like it's an array 145. But if I try to grab the first index of it, it's undefined, because you cannot do array accessing because it's not actually an array. So I might get object here. That's fine. So this is a, but let's do instance of linked, or list node. Yeah. So it really is a list node. It's just when it logs, it looks like it's an array, but it's really not an array. All right, so that is what was confusing me about this, is that the code was assuming that it was already a list node, and I thought that it was an array that I was going to have to coerce to list node. But no, they're really already list nodes. Okay, so L1 and L2 are list nodes. Great, so we're actually working with linked lists. Hallelujah. I'm actually super stoked about that. Probably the first time I've been stoked to actually have a linked list. Although we should be done with the problem now. It's been half an hour. So yeah, we're going to just copy. So while there is a remaining node, we haven't hit a null yet we have not hit a null yet on either linked list, then we will continue to compare and stitch. So if L1.val is we want to push the smaller one. And if it's equal, it doesn't matter. So if L1.val is less than or equal to L2.val, then we will use we'll point pointer dot next. Is it next? Dot next is L1. And then what? Do I call pointer dot next? Pointer dot next is L1, and L1 is okay. L1 is L1 dot next. That's how I progress. That's how I progress down L1. Okay, cool. How else do we do this for L2? So you move the pointer down L2. And what is this bit of logic? L1 is point.next.next. So we're sort of like always going back to L1. We're treating the L1 list as like the kind of the main list in a sense. Oh no, this is wrong. Okay, so it's not symmetrical. Can't you just sort the array? It's not an array. It's a linked list. And sorting it is not good enough. We want to do a merge sort because we want to take two lists and make them into one list. So we're merging and sorting at the same time is exactly what we're doing right here. Or you need a pointer because it's in a list of arrays. I'm confused. Hey, if you don't get it, no problem. This is like an extremely advanced problem. It's like, if you're like a kind of like a junior to mid programmer and this doesn't make sense, like don't stress out. We need pointers because there's three arrays here. There's L1, L2, and what we're calling head. None of these are actually arrays, by the way. They're linked lists, which is an array-like structure, but it's not an array technically. So we need the pointer because we are not sure at any given moment, we're not sure whether the next node in the head, the third list that we're building, we're not sure if the next node should come from L1 or L2. So we have a pointer that can point back and forth between the two. So that's the reason that we need the pointer. Okay, so L2 equals L1, and L1 is pointer.next.next. L2 is L1. Why did we do that? Yeah, so we're basically treat L1 as main tracking branch for head. So we set L2, I think that's unnecessary, but I'll go with it because we're not here to question things. Basically, we're always treating L1 as the main tracking branch. And I'm not really sure why that's necessary, but that's the way it's implemented, so we'll go with it. So while L1 and L2, that's our while loop. And pointer, and we progress our pointer. So eventually the while loop will terminate because we're progressing down both trees, down both linked lists. Now that we are at the very end, it could be that we're at the very end of one, but we're not at the very end of both. So that's what we need to take care of now. Does it matter in which line you put commands in? Yes, it does. We're serially executed left to right, top to bottom. So now we're going to handle that we could be at bottom of one list but not other. So if not L1, then point.next equals L2, else point. This is a stupid way to write this, right? It should be if L1. If L1 point.next equals L1. Why would you do not? All right, cool. Let's see what happens. Pointer.next equals L1 cannot set properties of undefined setting next. Pointer. Pointer is head. Head is list node. A list node should have next. All right, let's try changing the infinity to a 0. Okay, so that didn't fix it, which is kind of good, because I would be confused why 0 could work and infinity could not work. So cannot set properties of undefined. Y is next. Yeah, Y is pointer undefined. So pointer has become undefined somehow. Let's log right here. It may be the case that it's initially defined and later loses its definition. Okay, no, it's undefined from the beginning. So this is problematic. Head and pointer are both undefined. Ah, because I didn't use the stupid new keyword. Hello. Okay, so 1, 2, 4, 5, 6 expected. Oh, it wanted. It wanted duplicate numbers. Okay, that's interesting. Let's see. Am I eliminating duplicates somehow? Merge sort to lists. Okay. Let me slow down for half a second. 1, 2, 4, 5, 6. Oh no, I don't have 3 there. 1, 2, 4, 5, 6. So I'm simply missing 1, 3, 4. Ah, I think I know what might be going on. The splice could be throwing off the index. Because I basically merged the first and the last. Yep, okay, so 2 merge, I didn't actually put, here's list 1, I didn't actually put 2 merge there. Do you not need num++ for the pointer? No, we are doing pointer equals pointer dot next. So it's not an integer-based pointer, it is a reference-based pointer. So what's happening with 2 merge here? It's like, that's not good. Let's just basic debugging. Let's do constant result and log the result. Now we can see at each iteration what is our merge result and see is that what we expect. So result, I hit result twice, which is exactly what I expect because I start with 3, so I should splice twice and 1 remains. So I'm iterating the correct number of iterations, but is the sort of like values, are those correct? Let's also log to merge in lists. So with list, we start with an input 3 long, and we should splice out the middle, 1, 3, 4, which we do. So we splice out 1, 3, 4, 2 merge becomes 1, 3, 4. This is what we expect. So my inputs into merge to sort lists should be 1, 4, 5, and 1, 3, 4. So my result is not correct. My result is not correct. My result should be the merge of 1, 4, 5 and 1, 3, 4. Instead, it's like there's 2 separate lists. result, and next. Okay, I need to remember that I'm looking at like a representation of a list node. Yeah, it's just returning my to merge. It's just returning the L2. It's not actually like traversing or merging anything. And I don't know how the undefines are showing up. Like, none of these say undefined. Let's just log lists 1. I'll call this final. Yeah, so final has no undefined. It's not pointing at nodes, it's like pointing at whole lists. So I can see the problem here. The next I can see the merge problem. So it's got all 3 elements. But they're not merged. They're like not flat. They're sort of like a list of lists. So I can see that problem. But my other concern is that final and output don't say the same thing. I think that's just a matter of how Leetcode is logging the list node entity. So I think that's just an annoyance. Yeah, so it's sort of like writing their flattened representations. Which is pretty confusing as a debugging tool. That's pretty confusing. Okay. Let's just go over this code one more time. Head and pointer to this new list node. We can make it 0. It doesn't matter. That won't impact anything. Yeah, it doesn't matter. Well, L1 and L2. L1.val is less than or equal to L2.val. Pointer.next is L1. L1 is L1.next. So going down the L1 list. Okay. If else, pointer.next is L2, L2 is L1, L1 is pointer.next.next. Pointer is pointer.next. Let's flip these. This is the only case where I switched any of the code. So if not, it'll be if not L1, pointer.next is L2. And this could totally be the problem. It's just kind of lost on me why. I'm like pretty glad that that did not fix it actually, because if that fixed it, I would be baffled about why. So let's confirm. Yeah, we have final here. 26134.145. And I want to just confirm that that did not change. So if L1 remains, pointer.next is L1. Otherwise, pointer.next is L2. Two six one three four 145. Two six 134 145. Okay, cool. So the only code that I actually changed from the merge sort accepted solution, the only code that I changed didn't actually impact the correctness, which is what I thought. And I think it improves the intuition, like readability and intuition. So I'm happy with my merge sort. Did I screw something else? Did I screw something up in the not merge sort part? It's like here in the not merge sort part, this is the binary search solution. I was trying to do one by one before I did binary search. No, I'm really upset about this result. The result is not correct. It's not interleaving the nodes as expected. 134 145. It should be 13445. I like more to build websites with JavaScript and PHP, but this is also interesting. Yeah, building websites is way better. This is just for interview prep. This is like, I'm not a fan of Leetcode. So we have L1 and L2. I tried to understand what you're doing, but I think I just need to learn a bit more. Yeah. Leetcode is like its own style of programming. It's very foreign if you haven't done it before. Check out this article right here that I wrote. 5 to 23 patterns. This is an improvement over a famous article called the 14 patterns article. And this will help you understand algorithm style problems. So I want to know why do you want to apply to Google? I have a final with Google in an hour. I've already applied to Google. I'm going into the final round. Wish me luck. I'm also sick with COVID, so that's awesome. Something is not right here. Thank you, Jorge. That's nice of you to say. Something is not right here. I logged something called final. Let me look at this in a language other than Python. I'm expecting that I should actually get to the single value level, like 134. Everything is Python, 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 Python. Here's an approach in Java, okay? Add dot value. So they're actually going to the value. Okay, so this is a different way to do it. They just, for list node and lists, they just, okay, this is approach one. They just dump all of the nodes into a single list and sort it. That's really inefficient, right? That's the brute force approach. Got it. Yeah, okay. Um, merge to list method. This is what I'm looking for. So they return answer.next. Okay, so they're not returning head.next, they're returning answer.next. Oh, they like did it backwards. So they're appending onto head. I told you sort, listen to me. That's hilarious. So they create a head reference and an answer reference. So they changed the equality condition. They actually changed the merge sort logic here, like non-trivially. So I like the approach of returning head.next instead of answer.next. While L1 and L2 are not null, great. So they changed the equality condition here. They got rid of that. Does that do anything? 2, 6, 1, 3, 4, 1, 4, 5. I don't think it does anything. Okay. Let me just log the pointer. Cannot read properties of undefined. Reading next. I just add a console.log and that makes it error. Yeah, something weird is going on. I feel like there's like a silent error somewhere. Okay, so let me kind of do this my own way. I was trying to just like copy their solution, but it didn't seem to work. So something weird is here. Do you need to log the value of the pointer, or do the pointer already have the value? I'm trying to log it. So the pointer is pointing at an object. It's pointing at a list node, and there's something called listNode.val. That's where the value is, the primitive value of the number is held. So while L1 and L2, I'm going to say pointer equals pointer.next. And I just need to pick L1 or L2. So this logic seems fine to me. If the L1 value is less than or equal to the L2 value, then we will point at L1, and then we will, maybe this is the point. Maybe this is the part that I want to skip. Nope, I want to leave that. So it's like L1 remaining. Yeah, it could be this line could be the problem. So that's definitely included in the Python solution, but I don't seem to see it in the Java solution. Yeah, so the Java solution seems to... No, it doesn't omit it. It just includes it in the conditionals. I'm going to let me think about this. So the pointer dot next is L1. Yeah, I need to call it to actually move the pointer. I do need to call it. So then we're moving the pointer following list 1. So this will just do list 1, but it should work. It should like run. Cannot read properties of null. Yeah, so I shouldn't get null. Yeah, I'll get null. I could get null if L1 is greater than L2. All right, so I need to have the else condition there. All right, so now L1 is greater than L2. If L1 is greater than L2, L2 is what I'm going to push in next. So my pointer dot next is L2. Why am I doing this? This piece I don't understand. These, let me comment those. I'll just say L2 is L2 dot next. Why would this not work? So in this case, I'm saying L2 is where I'm going to like pick the next value. So the pointer will point at L2. Then the sort of like L2 remaining basket will move. And then at the end of my sort of like inner while loop, I've decided what the next pointer is going to be, and then I move to that point. Two, 6, 1, 3, 4, 1, 4, 5. So it didn't seem to work, but it also didn't seem to do anything different than before. So I kind of like this logic more. One thing that could be happening is merge sort two lists, maybe I should just like explode those when I pass them in. Is that like, are they doing that quickly and I just didn't notice it? So here I'll look at the Java solution, merge two lists, picks list I and list I plus one. It doesn't even destroy them. It doesn't even splice them. Yeah, maybe splicing is creating a problem because they're not really arrays. Okay, so I can try this. Let me comment this. To merge is not defined. Okay. Then I just get an infinite loop, huh? Yeah. So this Java solution is kind of not in place because it creates a new list and just loops through. Yeah. I can try that. What does the Python solution do? They're just using an ordinary for loop as well. While interval is less than amount. You need a better mic, John. Yeah, I agree. What's up, dude? Good to see you. Let's look over here. They just point you over here. Maybe I want to do recursion. O-N-M, O-N. So this is actually, so iteration is actually less space complexity. All right, so I don't want to do recursion. I want to do iteration. Yeah, it's like the same thing, isn't it? I'll copy this over here. This is like the same thing. So I have a head node, and then a pointer. Here it's called prev. I call it pointer. That's fine. While L1 and L2, that's what I do. There's a value comparison. Yeah. Thanks. People are like literally modifying the list node definition in Leetcode. Maybe I need to like create a new node every time. That seems like I shouldn't need to do that. So let's look up the discussion and just find a JavaScript solution. So they're saying while not null. I just said, okay, let's test this and see if that matters. This shouldn't matter, right? It shouldn't matter. Next is new list node. Yeah. So they actually have to create a new list node every time. All right, I think that's what I was missing, y'all. I guess you don't have to do that in Python. I'll make a note of that. What are you working on? Just interview prep. Okay, so here, pointer.next is L1. Let's do pointer.next is new list node L1.val. And similar for L2. I think I need to fix those as well. Output time limit exceeded. Oh, it's growing exponentially. That's cool. And why is that? So let's go back to splicing. Yeah. Where's the 0 coming from? I don't know where any of these zeros are coming from. Result 0, 1, 4, 5. One, 4, 5, and 2, 6. 1, 4, 5. Result lists to merge. So to merge 1, 3, 4. That is correct. merge two sorted lists, L1 and L2. Let's log pointer and L1 and L2 and head at each interval. So pointer got a 0 somehow. Because L2 is undefined, that's why. Okay, because L2 is undefined. Yeah, so I do need to explicitly check null because there can be an object there with a null value. All right, so that's also incorrect. Cannot read properties of undefined reading val. So is there actually a node with an undefined value? I'm wondering why L2 is undefined. So that should be to merge. You need to make a game I've been thinking of. I actually created a working text version, but I can't find the code. Make a GitHub, dude. I'll check it out. Here's to merge. To merge is working. But so here to merge is defined, and then in L2 it shows up undefined. Let's log it. There could be something goofy going on over here. Okay. So I still have L2. To merge is passed incorrectly as L2. Somehow L2 gets to be undefined by here. L1 and L2 are both defined, so we step in if L1.val is less than or equal to L2.val. She going for a nap?
I'm gonna try. I tried 10 minutes ago and she screamed. So now she's saying daddy.
Hey, little lady. Did she get a bottle?
Yeah.
Girl, you're covered in chocolate and stuff. Hi. Where's your baby? Do you have a bottle for her?
Me too. That's Sam's space.
Yeah, I'm not going to, but she wants a bottle. You want it down? Bye-bye.
Night, Daddy.
Yeah, the L2 val is undefined somehow. So L2 says 134, but L2.val, which should say, it should say 1. Oh, this is like, all right. Okay, I've got it. Look, you see L2 is wrapped in an array. That's the issue. How about that? Now L2 should say 1. Yeah. And that was accepted. Oh, mercy. Okay, so that was a total pain. So the issue was that splice was returning an array that contained the linked list instead of just the linked list. Which is totally logical. I mean, computer's always right. I guess that's not quite true, but it's pretty much true. So, cool. That took about 3 times as long as it should have. But I got some understanding out of it, yeah? Was able to improve the readability here, understand Python versus JavaScript node referencing here. So Python is a pass-by-object reference language, not a pass-by-reference, as implied in the question. Which is a tricky thing in Python that in JavaScript we should just create the new node and pass it that way because the pointer wasn't working. Well, I say the pointer wasn't working, but let's double check now that I have fixed that issue. So we'll do L1 here and L2 here. And that's also accepted. So I'll say or. So I think it's better not to create the new nodes. That's like extraneous operations. So I'll just point at it. The way we were pointing was not working because splice out array containing linked list. All right, so let's see. It's a runtime error. Is not a valid value for the expected. Okay, so I think that was another case of like how they are how do I do an empty linked list if I declare a list node? Whoa. So do I need to like explicitly pass null? What is this output 0? It's okay. The leet codiness of this question is so annoying. There's like yeah. List node is injected, and then the list node behavior is weird. Return head dot next. This is just to merge the thing. Can I just return lists in this case? Nope, can't return lists. Let's go see the Python solution once again. Else none. So what would the equivalent be in JavaScript? Either null or undefined. So that was accepted. So this is what I mean, like the leet codiness of this problem. You see example 2, they want this expected output. That looks like an array to me, but they want me to return null. Whatever, I'll take it. We got the W. Cool, so now I just need to, like, that's all we're gonna do today. Thanks for joining. I was supposed to be able to do this in 10 minutes, and it took me 80 minutes. So to optimize this, this is like a linear merge. You would want to turn this into a binary merge. But I don't have time. That's that step right there. If we have time to implement binary search. It's not really binary search. It's like binary interval merge. Binary interval merge. All right, so that's it for today. Thanks for joining, and see you later.